All right, let's look at question number 8 in paper 2, section B. We have a colorsome plane. All right, so let's transfer it on my answer space over here. Okay, so this is 90 degree. B is here. Point A is negative 5, 11. And then the equation of this straight line is 2y plus x plus 8 equals to 0. Okay, anything else? This is the origin. Now let's look at the question, yeah? In this diagram, angle ABC, so ABC is 90 degree, and the equation of straight line BC is given 2y plus x plus 8 equals to 0. So this is exactly what's given in the diagram. So what are we supposed to do? We are supposed to find the equation of straight line AB. Now to find the equation, okay, to find the equation of AB, we must have two things. One is a point, either A or B, which in this case we have A, so we just need one point. And another one is the gradient. Now, the gradient AB. Do we have gradient AB? Do you see this 90 degree perpendicular line? When two lines are perpendicular, therefore the MAB times MBC equals to negative 1. So we know about this. MAB times gradient BC equals to negative 1. So we are going to use this concept. Yeah? So do we know the gradient of BC? So let's write the equation of BC in gradient form. So if 2y equals to negative x minus 8, therefore y will equals to negative half x minus 4. So from here, we know that this is the equation of BC. So we know that the gradient of BC is negative half. If gradient of BC is negative half, therefore, based on this, the relationship between two perpendicular lines, the gradient of AB will be the negative, the reverse of negative will become positive. 1 over 2 will become 2. So that is the gradient of AB. Now with the point A and the gradient of AB, then we can find the equation of AB. So equation of AB will be y minus the point A. So the point A is negative 5, 11. So y minus 11 equals to mx minus the x, and x here is negative 5, so we have plus 5 over here. So we will have 2x plus 10 equals to y minus 11. So bring the minus 11 to the other side. We will have plus 11 over here. So y will equals to 2x plus 21. So that is the equation of AB. So we have found part A. Now, next, let's look at part B. Oh, part A. Part A1. So part A2, the coordinates of B. So if we have the equation of BC and AB, and B is the intersecting point between these two lines. So to find that point, we just solve these two equations simultaneously. Okay, so we have the equation of AB is this, equation of BC is that. So we substitute their y and equalize them. Okay, so let's call this equation 1. Let's call this equation 2. So we shall put equation 2 into equation 1. So this is at part 2. This is part 1. So put equation 2 into equation 1. So whenever I see y in equation 1, which is 2y equals to negative x minus 8. I shall replace with this 2x plus 21. So I will have 4x plus 42 plus x plus 8 equals to 0, yeah? Yeah, I shouldn't have bring the 8 over. Never mind. So 4x plus x is 5x. 42 plus 8 is 50. So bring to the other side will be negative 50. Therefore, x will equals to negative 10. So with that, we need to find the coordinates of B. So don't forget we need to have the y coordinates also. So from equation 2, y will be 2 times x plus 21, and the x is negative 10. So negative 20 plus 21, so we have 1. So we have just found the coordinates of B to be negative 10 and 1. And does it make sense? Well, based on the diagram, it's on the negative side of the quadrant of x and the positive y. So it makes sense. So we have just found the coordinates of B. Now, next, the part B. The straight line AB is extended to a point D such that AB to BD is 2 to 3. So the AB is being extended to D. And then we have A to B is 2 parts and B to D will be 3 parts. So let's write that down. In this case, we need to involve the ratio theorem. Okay, so we know that A to B, B to D is 2 is to 3. Let's write the coordinates of A here, which is negative 5, 11. And let's write the coordinates of D here, which we do not know what is that. So let's just leave it as x, y. And these two, when we cross multiply, we will get the coordinates of B. And the coordinates of B, which is what we have found just now, negative 10 and 1. So we need to apply the ratio theorem. How do we find that in the first place? The formula will be, because it's a coordinates, so the x coordinates from here, negative 5, cross multiply with the ratio of the opposite ratio, yeah? So negative 5 times 3 plus the x here times 2, so plus 2x, divided by the total ratio is 5 parts, and then the y coordinates will be 11 times 3 plus 2y over altogether 5 parts. And therefore, we just take out the x coordinates and compare with the x coordinates. So over here, we will have negative 5 times 3 is negative 15. Negative 15 plus 2x will equals to the x coordinates here times the 5 that I bring up. Okay? I take out each coordinate and compare accordingly. Okay? Now, so for this side, I will have 2x equals to negative 50 plus 15. So what do I have over here? I will have negative 35. Okay, so therefore x will equals to negative 35 divided by 2. So negative 35 divided by 2. And on the other hand, the 33 plus 2y equals to 11. 33 plus 2y equals to 1. So, and times 5. Yeah, this whole thing equals to this. So 2y will equals to 5 minus 33. So 5 minus 33, we will have negative 28. So if 2y equals to negative 28, y will equals to negative 14. So we had just found the coordinates of D, which is negative 35 over 2, negative 14. Okay, that's it for question number 8, part B. We still have the last part, part C. Part C say a point Q moves such that its distance from point A is always 6 units. It's always 6 units. Therefore, this one is a locus. So we have to find the locus of Q. So we know that from A, this is part C, from point A, okay, and we go, the locus will move such the way that it's always 6 units apart. So let's freeze. The point Q will fall into here. So isn't it the distance of AQ equals to 6? And since Q is a moving point, so we will just let Q to be generally X and Y. And point A we have. Point A is -5 and 11. So we just use the concept of distance to find. Yeah? So X minus the X, which is -5, become +5 squared, plus Y minus 11 squared equals to 6. This is square root. If I bring the square root across, then it will be square over this side. So expand this one, we will have x squared plus 10x plus 25 plus y squared minus 22y plus 121 equals to 36. Equals to 36. No space. Okay, so let's move everything onto the left-hand side. So we will have x squared plus y squared plus 10x minus 22y. Okay, group all the numbers together. So we will have 121 plus 25. So that one will be 136. 136 minus the 36 over here. So we become 100 equals to 0. So we have just found the equation of the locus Q. That's it for question number 8.